Hi, this is Dr. O'Connor. In this video, we're going to talk about amides. Now, amides are compounds that have a carbonyl group and a nitrogen atom group. Okay, so for example, what we have here is carbonyl group, and bonded to the carbonyl carbon is a nitrogen. Amides are different from amines. Remember, an amine just looks like this. Okay, the nitrogen is bonded to at least one carbon. The amide, on the other hand, has the carbonyl group and a nitrogen bonded to the carbonyl group. Now, as far as the nitrogen atom goes, it can be bonded to two hydrogens. It can be bonded to one hydrogen and an alkyl group or aryl group, or it can be bonded to two alkyl groups or aryl groups. All right. An unsubstituted amide is one that has two hydrogens bonded to the nitrogen. And an unsubstituted amide can form three strong hydrogen bonds to other amides. So that makes them higher boiling than even carboxylic acids. Okay. Low molecular mass unsubstituted amides are solids, and they're also soluble in water and organic solvents. So again, they're soluble in water because they can form hydrogen bonds with water. So here's an example: formamide, and this is a liquid. Monosubstituted amides, that'd be where the nitrogen is bonded to one hydrogen and then an organic group. They can hydrogen bond with other amide molecules. So intermolecular hydrogen bonding does take place. Now, a disubstituted amide, on the other hand, it cannot hydrogen bond with another disubstituted amide, okay? And let's take a look at this. So we have this, okay? So here we have two R groups. So we don't have a hydrogen here bonded to a nitrogen, okay? So that'd be disubstituted. So we refer to amides as being non-substituted, monosubstituted, or disubstituted. Also, just so you know, some people pronounce the word amide as amide or amide. Okay, so you'll hear it pronounced both ways. I sometimes use both ways. I'll sometimes pronounce it as amide, other times amide. Amides are not basic. Yes, there is the lone pair of electrons on the nitrogen, but what happens is you have this carbonyl group here, and remember that the electrons are being pulled to the very electronegative oxygen, so that's leaving a partial positive charge on the carbon. So that carbon is pulling those unshared electrons. So that means that amides are not basic. They don't undergo the same reactions as amines. Let's go ahead and name the amides. I'm not going to go into too much detail here. Amides with unsubstituted amino group are named by replacing the IC in the acid or the OIC with the word amide. So what we would do is we would name it as a carboxylic acid and then replace that ending with amide. Okay? Substituted amides are named by first specifying the alkyl group and then identifying the amide name. So just like with amines, the alkyl substituents are preceded by the letter N in order to show that those alkyl groups are indeed attached to the nitrogen. For example, here we have acetic acid. So we would replace the IC with the word amide. So this would be acetamide. Now, these are the common names, right? The IUPAC name for acetic acid is ethanoic acid. Okay, so this would be ethanamide. Let's go ahead and name this one here. Sometimes it's better to draw this part out. Okay, so we'll go ahead and draw this out. So we have CH2, CH2. Here's our carbonyl group. Here we have the nitrogen one hydrogen, and a methyl group. So we'll go ahead and name this as the acid. Okay, so this would be a 4-carbon acid, so this would be butanoic acid. So we would call this butanamide. Okay, and then we have an methyl group here on the nitrogen, so this is a monosubstituted amide, so this would be N-methyl butanamide. And then this one here, well, we have a benzene ring here, and we would forget about the chlorine for now. Okay, let's just go ahead and name the acid part here. This would be benzoic acid, but here we know that we have an amide, so that part would be benzoic acid. Replace the OIC with amide, so this would be benzamide. Okay, and here we have a chlorine. Okay, and here bonded to the nitrogen we have a methyl group, so that'd be N-methyl, and then para to the carbonyl group we have a chlorine, so this would be P-chloral. So let's go ahead and put this together. So what we would have then is a P-chloro and methyl benzamide. Okay, let's take a look at some examples here. Here we've all heard of acetaminophen, and this is an amide. We see here the carbonyl group, carbonyl carbon bonded to a nitrogen. And this also contains a hydroxyl group. So this is best known as Tylenol. And this is an alternative to aspirin, but it's mainly used for pain relief, and unlike aspirin, it is not an anti-inflammatory agent. It doesn't cause bleeding like aspirin, but it can cause liver and kidney damage if you take too much of it. Here's an amine here, okay, benzocaine. Again, the difference between the amine and the amide is that nitrogen, in this case, is not bonded to the carbonyl group. This here is lidocaine, and this one here is an amide. You have carbonyl carbon bonded to the nitrogen. So we're going to see a lot of these structures later when we get into the biochemistry. So how are amides formed? Well, an unsubstituted amide is formed by warming a carboxylic acid with ammonia. And just like the other reactions we looked at, it's this group here is going to be substituted. So what will happen is one of the nitrogen hydrogen bonds will break in this ammonia molecule. The hydrogen will combine with the hydroxide ion to form water, and then a bond forms between the nitrogen and carbonyl carbon. So this is how you would prepare an unsubstituted amide. So you just go ahead and choose whatever carboxylic acid you want. That's going to depend on the structure of the product that you desire. So again, unsubstituted amides react with a carboxylic acid and ammonia. A substituted amide is formed by warming a mixture of a carboxylic acid with either a primary or a secondary amine. So in this case here, we warm acetic acid with methylamine. What's going to happen is one of these nitrogen hydrogen bonds is going to break. This bond here is going to break. The hydroxide ion and the proton, or the hydrogen ion, will combine to form water, and then a bond will form between this nitrogen and the carbonyl carbon. So here we form an amide, in this case a monosubstituted amide. If I wanted a disubstituted amide, I'd make sure that I use a secondary amine. So make sure that you recognize these reactions and practice them so that you can predict the products. Amide hydrolysis, okay, just like we talked about ester hydrolysis. So we start off with an amide. We heat the amides in the presence of a base or acid. So in this case here, we have the amide, okay. Here is the water. And what's going to happen is this bond here is going to break. It's actually the reverse of the formation of an amide. And this bond will break. The hydrogen will go with this part to form the amine. And this OH will go ahead and bond, oxygen will bond to the carbon to form the carboxylic acid. So the products are a carboxylic acid and an amine. Again, take a look at those reactions. We talked about polyesters before, so we're not going to talk about them here, but there are polymers called polyamides, and nylon is a polyamide. And what we have to do is react a diamine, so a molecule that has two of these nitrogens, with a diacid. So what we can do in the lab is we can heat some adipic acid, hexane dioic acid, with hexamethylene diamine. So this is a diamine, has the two nitrogens. We heat those, and what we can do is take a stirring rod, and then right at the interface between the two, we can just start pulling up these strands, okay, and we end up with this nylon. So that's a very interesting demonstration, if you will. So, and this is what it looks like. We have the diacid, the diamine, okay, and we go ahead and heat that, and then it undergoes a polymerization reaction, forming these amide bonds. So we see right here, we have the carbonyl group bonded to the nitrogen, just like the reaction that we saw, the formation of the amide. And so remember, a polymer, you're going to have these repeating units, hundreds, thousands of these repeating units here. We all know about nylon. It's used in clothing, ropes, rugs, and those types of things. Also, it can be used as suture material and also in replacement arteries. So many uses for these polymers. Well, that's it as far as the amides go. Again, I didn't cover everything that was in the chapter about amides, but the only material you're going to be responsible for is what I went over in the video. So have a great evening. And again, if you have questions, please let me know.